Equation of circle, part 4. Turn to page 20. In this video, I would like to introduce the relationship of the intersection between a straight line and circle. Let's see one of the example. How many points of intersection do the straight line x plus y is equal to 4 and the circle x squared plus y squared is equal to 8? That means maybe if you draw a circle and consider one straight line, there are three possibilities. Okay, one is the straight line does not intersect the circle. The second case, okay, maybe the straight line intersect the circle and with two intersections. But the last case, how about the case between no intersection and two intersection point? If the straight line is touch the circle, that means we have one intersection point. How can we determine the point of intersections between a straight line and the number of point of intersections between a straight line and circle? Maybe the first idea, okay, is that you try to plot it, try to find the intersection point. If you can find two intersection point, then that means we have two intersection point. If we cannot solve it, okay, we cannot find the intersection point, that means we can find that means they do not touch, that means no intersection point. If we find one intersection point, that means the straight line. But how can we find the intersection point between a circle and straight line? The idea is simple, but why? Because can you observe in this equation we have two variables, okay, and this equation also have two variables. I know, for example, I let A, B be the point of intersection. If I want to find the exact values of the point of intersection, that means I know A and B must be satisfy this equation, and A and B also satisfy this equation. If we can find the values of A and B, that means we can find the point of intersection. How to find it? One equation with two unknown, maybe we can use the method of substitution to eliminate one of the unknown from 1. A is equal to 4 minus B. This is equation 3. Substitute 3 into 2. 4 minus B all square plus B square is equal to 8. Then 16 minus 8B plus B square is equal to 8. Simplify it. I know 2B square minus 8B minus plus 8 is equal to 0. B square minus 4B plus 4 is equal to 0. Okay, and you may make good use of your calculator. B is equal to 2. And do we need to find the values of A? Okay, maybe you can find substitutes. B is equal to 2 into 3. I know A is equal to 4 minus 2. A is equal to 2. So that A and B is equal to 2 and 2. One solution only. That means we have one intersection point. Maybe you will ask, Mr. Chip, after you find the x-coordinate, the y-coordinate of the intersection point, we have one and only one solution. That means you substitute back into this equation we substitute back into this equation, we have one solution only. That means we can skip this part. We can also draw the conclusion. Yes, you are correct. Next time, if you want to determine how many the number of point of intersection, that means you can stop here. After finding the coordinate, the values of b, if we have one and only one values of b, that means one point of intersection. And maybe you will ask, but can you see you only need to determine the point of intersections, the number of point of intersections. That means you do not need to find the exact values of b, am I correct? So, next time, maybe you can use another way to solve it. That means I do not need to find the exact values of b. That means you can also skip this part. But we use another way to find it. That means if I only need to determine the number of roots of this quadratic equations, the number of roots of this quadratic equation, okay, we have another way, which is we can consider delta. Delta is equal to b squared minus 4ac. The answer is 0. So, one point of intersection. What I want to point out is that because you only need to determine the number of point of intersection, that means you do not need to find the exact values of a, yes. So you can skip this part. Also, because you only need to find the number of point of intersection, you do not need to know the exact values of b. You can also skip this part. If the delta is equal to 0, that means this case, delta is equal to 0 is this case. How about next time? If you find the delta is greater than 0. If delta is greater than 0, that means two intersection points. We have two roots, two intersection points. You can find two values. That means this case. How about the last case? If next time, if delta is less than 0, that means we cannot find the exact values of b. We cannot find the one of the coordinates satisfy both equations. So, the last case. Why I want to emphasize this idea, because sometimes, for exercise 12, consider a straight line. We have straight line, a circle. I need to determine the range of the values of k. This is the constant of the equation of circle, such that the circle and the straight line have no point of intersections. In this case, you cannot find the exact values of b. But how can we find the range of the values of k? We can make good use of this idea. Let's do it together. Let A, B be the point of intersections. The coordinate of the point of intersection. I know 2a plus 1 is equal to b. I want to make subject first. Okay, this is equation 1. And a squared plus b squared minus 4a plus k is equal to 0. This is equation 2. Substitute 1 into 2. A squared plus 2a plus 1 all squared minus 4a plus k is equal to 0. Expand it and simplify it. This is equal to 5a squared, and then plus 4a minus 4a is equal to 0, and then plus 1 plus k is equal to 0. It is because no point of intersection. I know delta is less than 0. B squared minus 4a times c is less than 0. So it's equal to negative 20. If I were you, I will not divide negative 20 on both sides or cancel it out because this is not equal sign. I will plus 20 times 1 plus k on both sides, so I can remove this term to the left hand side, right hand side. So it's 20 times 1 plus. Now all the coefficient is positive. I can divide 20 on both sides, and then I know 1 plus k is greater than 0. So minus 1 on both sides, I know k is greater than negative 1. This is the final answer. So next time, if you want to determine the number of point of intersection, you can just consider delta. Then done. You can find the and you can determine the number of point of intersections. If I know the information related to the number of point of intersection, just like this one, we can also make good use of it to find the range or find the exact values of k. But sometimes you also need to solve it, okay, by finding the exact values. Just like example 7.13, you may try to do it, because this time you need to find the exact find the coordinate, find the coordinate of the point of intersection. That means you need to use the method of eliminations and try to solve it. Maybe you try to do these questions, and we can go back to our lesson and try to discuss some more difficult questions.